So we're back for our second look at logarithms, and we are technically on example 3 in your book on page 469. So go ahead and turn in your book to that page, and let's look at example 3, and we are going to be evaluating logarithm expressions. So let me just come right up here, and this is Honors Algebra 2. We are on example 3, which says evaluate log expressions. And if you're ready, we'll just jump right into it. So let's have one that says log base 3 of 81. So log base 3 of 81. And notice it doesn't equal anything, so we need to put something over there. Well, log base 3 of 81 equals y, x, something. Okay. What does it equal? We need to try to figure that out. So let's think about the definition of a logarithm, because right now we're not quite so sure about that. So log base 3 of 81. So let's think in our minds, because later on I'm going to show you how you can do this. You'll be able to put this in your phone or do what you need to do. But let's think about the exponential form, and let's rewrite it. Because what question are we technically asking? Well, we're asking, what exponent would I raise 3, the base 3, to get 81? So in other words, 3 to the what is 81? That's the question that we're asking. This guy right here. Yeah. What power do I raise 3 to and get 81? That's what this question asks right here. The logarithm of base 3, logarithm base 3 of 81 equals what? And again, what am I really asking? I'm saying, what exponent would I have to raise 3 to get 81? Well, one of the things that we're going to do is we're going to use our property of equality that we did back before spring break on exponentials. We're going to use that property of equality. And remember, it said this, b to the x equals b to the y. Okay, when is this true? That means x has to equal y. So we're going to use this because this is what we know, or this is what we've done. So we're going to use this to help us figure this out. Alrighty? So let's remember that 3 to the y equals 81. Right, so now how can I solve this? I can solve this using my property equality if my bases are the same. Well, right now, guess what? They're not the same. So the question that you ask, how can I rewrite 81 using base 3? Can I? So let's come over here. Can I rewrite 81 using base 3? And you think about it, right? Well, 3 squared is 9, 3 cubed is 27, 3 to the 4th, right? So that's what we're going to do. We'll rewrite 81. 3 to the y is equal to what? 3 to the 4th, because 81 is 3 to the 4th power. And now what do you notice? Oh, look, my bases are the same. So can I set my exponents equal to each other? And the answer is y. Yes, you can. How about that? All right. So log base 3 equals 81. No, I said that wrong. Sorry. Log base 3 of 81 equals y. right? So what did we do? We rewrote it. 3 to the y equals 81. We use our property of equality for exponentials that says if my bases are the same, I can set my exponents equal to each other and solve. Well, over here, 3 and 81 are not the same, but I can rewrite 81 using base 3. 3 to the fourth is 81. So now, back, are my bases the same? Well, yeah, they are. They're both base 3. So now what? Can you set y equal to 4? You can. And we've done example 3. So let's do another one. Alrighty? I'm going to go to the next page. And let's do example 3b. And what are we still doing? We're evaluating the log. And how are we doing it? By using what we know, because we don't know much about logs yet. They're all kind of brand new. We're going to use what we know about exponential functions. And why can we do that? Because logarithms and exponentials are inverses, like squaring and square rooting, like cubing and cube rooting. They're exponential, they're inverse functions. So let's try another one. How about log? And let's do an even one over here. So maybe let's do like 32 log base 121 of 11 equals, actually it doesn't have the equal sign in the problem, does it? It just has that, okay? So what's the question we're asking? What power would I raise 121 to get 11? Okay. So let's get the pen back. We don't know. All right, so rewrite it. All right. So base 121, 121 to the what power equals 11? Well, I can use my property of equality for exponentials if my bases are the same, but as you look at them, they're not the same. And so the question we ask is, can I rewrite which one? I'm going to rewrite the larger term using, if possible, the base and the smaller. So can I rewrite 121 using base 11? We can. So 121 is the same as 11 squared. So remember, that goes inside the parentheses, and then this exponent goes on the outside. So 11 squared raised to the y power equals 11. And remember what happens here when you raise a power to a power. Do you remember what you do with your exponents? That's right, we multiply them. So 11 to the second power to the y power is 11 to the 2 times y. So we get 11 to the 2y power equals 11. And now right off the bat, you're like, what the heck? Where's the exponent over here? Well, we don't see him. So what is an understood exponent? It's 1. There we go. So now my bases are the same. Can I set my exponents equal to each other? Yes, I can. So 2y equals 1. Let's divide both sides by 2. Y equals 1/2. So 1/2, and 1/2 power, we recognize that as what? The square root. So let's see if that makes sense. Is the square root of 121 11? Well, hot dog, it is. So we have successfully worked this problem. If you look, let's do one more, all right? Let's do this one. Log, let's do a fraction. 1 log base 1/8. of 512. I'm trying to do all possible options here. Log base 1/8 of 512. And so same kind of thing. I want to know what the log, what log value would I raise 1/8 to? I'm sorry, what exponent would I raise 1/8 to get 512? That's the question that I'm asking. Well, let's just stick a variable over there. And now I can solve this by rewriting. So that's what I did over here. I should rewrite in expo form. So that's what I did. And then what did I do? And then rewrite in same base. And then what did we do? Set exponents equal to each other and solve. So these are our steps. So let's come over here. Okay, let's rewrite this in exponential form. So this is my base, log base 1/8 of 512 equals y. So I'm going to say 1/8 to the y power equals 512. And then I'm going to look at that and go, oh no, fractions, right? And then I'm going to start to do what? Have this puddle of tears over here because some of you are so concerned about fractions. But you know what? We're going to say, it's okay. We can do it. We can do it. Yes. So let's think. 512. What am I trying to do? I'm trying to rewrite them in the same base. Well, let's think. 512 is a big number. 512 to the sum, that's not going to work. So what do you bet? Wonder what my base could be. Well, I have an 8 here. So let me just play around on my calculator. Let me think. 8 to the first is 8. 8 squared is 64. 8 to the third power. Guess what 8 to the third power is? 512, right? So let's rewrite these and use base 8. So let's see, rewrite and use base 8. Well, this is 1/8, and I need to rewrite him too. So 8 to the what power is 1/8? Do you remember our reciprocal? It's going to be 8 to the -1 power. And that goes in the inside in the parentheses, and then who goes on the outside? Y. Equals, now let's rewrite 512 using base 8. And it's 8 to the third, just like we talked about. Okay, now what? Well, I'm simplify this. So when I take a power to a power, I multiply. So 8 to the -1y equals 8 to the third. And now I look at it and say, well, hey, my bases are the same. If my bases are the same, can I set my exponents equal to each other and solve? And the answer is yes. So let's do that. -1y equals 3. So y equals -1/3. All right, and I look at that. So over here we had what? When it was 1/2, that was the square root. Well, 1/3 is the cube root, but it's a what? This negative on there means reciprocal. All right, the reciprocal. The cube root of 512 is 8. The reciprocal of the cube root of 512 is 1/8. That's what that says right there. Oops, I didn't mean to do that. There we go. Okay. All right. So here's what you're going to need to do. You're going to need to look in your book, and I have asked for you to do 1 through 7 odd, and then I've asked for you to do 13 through 35 odd. And you know the good thing about being odd is it's in the back. Okay. So once you've done that, go ahead and submit or click on the turned in piece that will be on your Google Classroom. And we will talk about these tomorrow during our Zoom. Please that you can ask questions. That's what tomorrow is about. But make sure that you've watched the videos and that you've worked through the examples and that you've tried to work the problems before you ask lots of questions. All righty? That would be great. I'm proud of you all. I know this is not what any of us expected, but we can do it. So until I see you tomorrow on Zoom, be loved, be blessed. You're my favorites. Bye.